Okay, so here I want to show you an example of how to find the equation of a perpendicular bisector. And this is a set of directions I just went over in a separate video you can reference, but you're welcome to just take a screenshot of that or read them or pause it or whatever you'd like to do. And we'll go ahead and do an example. The problem says write an equation in point-slope form for the perpendicular bisector. Let me go ahead and write this out. Write an equation, and I'm going to leave out the in point-slope form, for the perpendicular bisector of the segment with endpoints P, which is 5, 2, excuse me, and Q, which is 1, negative 4. All right, so the first thing you want to do is just roughly graph it. It does not have to be a perfect graph. Just sort of get a picture in your head of where these things are. 5, 2 is out and up a little bit. That's P, and Q is 1, negative 4, so it's down here somewhere. So that's PQ. Now, looking at this again, my first step is to find the midpoint. Okay, that's because the perpendicular bisector would go right through the middle of the segment, and that's the midpoint. So first I need to do the midpoint of PQ. The midpoint formula says average the x's, average the y's. Okay, that means add them together and divide by 2. So 5 plus 1 divided by 2, and 2 plus negative 4 divided by 2. Remember, you're adding, not subtracting. This is adding a negative 4 is why it turned to subtraction here. So 6 divided by 2 is 3, and negative 2 divided by 2 is negative 1. So that is what this point is going to be, 3, negative 1. All right, remember this was a rough sketch, so it's okay if it doesn't look like it's a 3, negative 1. This one actually happens to, but that's all right if it doesn't. The next step, remember, was find the slope of the segment that's being bisected. So in other words, I want the slope of PQ. The slope of PQ, slope formula is the difference in the y's, so 2, that's the y for P, minus negative 4, over the difference between the x's, 5 minus 1. So this gives me 6 over 4, which is 3/2. Now, the reason we need the slope of PQ is because any line that is perpendicular to that, I can find out that line's slope by taking this number, flipping it over, and changing the sign. Any two lines that are perpendicular to each other have what we call opposite reciprocal or negative reciprocal slopes. So that means to find the slope of one, then the slope of the bisector is going to be that number flipped over and the sign changed. So it's going to be negative 2/3. So that's really what I was going for. I don't really need PQ's slope. I only needed it so that I could find this. So now here's what I know about that dotted line. I know its slope, and I know a point that it goes through. If you know the slope of a line and a point that's on the line, you can go ahead and use the point-slope form of a line and plug into that, and you'll have the right equation. So my point that's on my dotted line here is 3, negative 1. 3 is the x value, it goes right here. Negative 1 is the y value, it goes right here. Excuse me. I also know the slope. It's negative 2/3. So that's in place of m. So I have x minus 3 over here. Y minus the negative 1 becomes y plus 1. So I'm going to write y plus 1 equals negative 2/3 x minus 3, and you can leave it just like that. You don't even have to use distributive property or anything like that. And you're done.